layers of glasses are there. Okay. Now, so when we are placing, so what is happening inside? You see, this is just showing, suppose this is a touch screen and this one is our finger. Just here we are making it magnified. Okay, or sorry, it is, we are making smaller here. Okay, this part. What is happening? These two layers are there. So when we touch, basically we are deformed one of the layers. And when it is deformed, basically it is touching to the other layer. Okay? So then it is called a resistive touch screen. So that means that when it will, these two layers or these two, glass materials, they are basically yeah, when you will touch, then you can get the contact. But the problem is that if, that's why it is very delicate, right? And you are using some screen on the touch screen such that it should not be getting damaged. So that is the reason. Now, this one is a capacitive touchscreen technology. What is the difference here? That there is also the two glass are there. But here you can see there is a matrix. Matrix system means here you can do the X and Y. In X axis and Y axis you are making the mesh. You know the mesh, right? Okay. So this mesh, and here you can, it is very precise. Nowadays it is very precise. And there, whatever the pressure you are applying here, and if you use, when you are applying the pressure here, that is just basically electrostatic field. You know electrostatic field? What is electrostatic field? I think you people are always, you know these things. In winter season, we are using the comb and rub over here, and then it will be attached to the paper. So this is nothing but a good example of electrostatic field. The electrostatic energy. So for electrostatic, what is the minimum requirement? It should be insulated, right? It should be insulated. So that is the insulator, two of the insulator systems. But if it is the electrostatic field, then what will be the things? It will be attracted. So that is happening here. You can see whatever the pressure you are given here, and that is just reflected to the other one, and in between this, there you can see these things are there. This is basically the, I don't know the name. So this is IC, some accessible part. Here it is, there is some IC. This IC will make the changes. So basically it is a capacitive. I don't know these things. What is the name? I forgot it. I read but I forgot it. Very frankly speaking. So whatever the things I want to say, that there is the two layers of glass. When you are applying the force here, force means what? No mechanical force, electrostatic force. That means we have lots of charges on our finger. We are just basically communicate with these charges, and when it will touch, then what will happen? It will be getting attracted, or the other part, the electrostatic field caused by the touch, and then it will generate some charges. And electrostatic charge is what? You know these things, capacitor. There is an insulator medium. If you have a charge in one part, then other image charges will be formed in the other parts. Understand? So like this way, you are basically getting the gathering of the charges, and if you get the charges, this will be communicated, and whatever the information you want to share, or you want to give, or you want to take, that will be easily displayed on the display. So that is the basic mechanism. And now you tell me why the nail cannot able to. So it is a capacitive or resistive? Where the nail is not working?
Resistive.
Okay. Resistive or capacitive? Huh? Raise your hand. How many are saying capacitive? Sir, you are absolutely correct. Because it is capacitive. Why it is capacitive? You are not giving any charges. Nail means it is insulated. Nail is insulated. Finger is here. You are getting lots of charges are here, but on the nail there is no charges. So that's why it is a capacitive. What we are using now, and that's why it is a very precise, and you are basically making the mesh, and that's why you are getting this type of. You see here it is given showing that the touch is you can touch anywhere, but if you use a nail or any kinds of insulating substance, it is not, you will not get any response. You will do it with wood, it will be not. It is happening? Okay. So I think it is last slide. I should conclude. Sir, how much time, sir? So any question? Any question? I ask any question? Thank you.
Thank you so much, sir. Now I request Dr. Rabindranath Bera to please offer a memento to Dr. Chatterjee as a token of appreciation from the family of Spring School.
Really enjoyed this lecture. Touched my heart heavily. Okay, with the demonstration. It's been motivation for me. I think. Should it motivate you, the students?
Yes, sir.
Please. Now, Dr. Chatterjee has told some problem, constant sitting on India. Yeah, is the problem. Is the problem. But I have some different opinion whether you agree or not. Constant, okay, I have cited an example. Constant may be the blessing.
Yes.
Suppose I am speaking it here. If my voice is not attenuated, please listen. If my voice is attenuated, if my voice reaches to Siliguri or to US without anything, can we survive? Everybody is speaking, everybody is speaking. Okay, my voice is propagated over US, to US. Okay, directly. So this is the constant. Atmosphere restrict my voice. If atmosphere does not restrict my voice, it will propagate to US, it will propagate to Japan. Not everybody will be speaking. Millions of people. We cannot survive. So effectively, constant is a requirement. Resistance is a requirement. Without resistance, I cannot work. Sitting in India is facing lots of constant, especially at secondary SMIT also. Lots of constant research facilities are not there at all. Okay, but okay, constant are in the sense blessings. Whether he will agree or not, I don't know.
No, I definitely agree.
But sitting in India, he is guiding somebody in foreign countries. Really gives something. Really something. It touches me, my heart, heavily. Okay, I am motivated. Okay. So, as a token of love, please accept.
Thank you so much, sir. We come to the end of second day workshop on MNDC, and that we have really added a lot to our knowledge. I would like to thank all the speakers of the day, Dr. Arijit Vishnu, ISI Kolkata, Dr. Krishnandu Mukhopadhyay, ISI Kolkata, Dr. Navadita Das, ISI Kolkata, Dr. Gautam Kumar Adhya, General Manager, BPNL Kolkata, Dr. Saurabh Dar, SMIT SMU, Dr. Somnath Chatterjee, SMIT SMU. Thank you all for attending the session. We hope to meet you all tomorrow at 9:30 a.m. with same zeal and enthusiasm. Thank you and good night.
জার্নিটা বেশ রিভাইভ